In this video, we are going to be graphing some linear equations. In the last video, we were finding x and y intercepts and just plotting those 2 points. Typically, graphing is really not about finding a bunch of points and then plotting them and trying to draw your graph. Typically, you want to figure out where to start and if there's some sort of a pattern associated with it. And that's what we're about to do with linear equations. We're going to turn our equations into what we call slope-intercept form. And slope-intercept form looks like this, mx plus b. Okay, so that is what we want our equation to look like. So this m in this equation, so your x and your y are your coordinate, right? They're kind of your unknowns or they're your samples. The m specifically represents slope. Okay, so there's a couple ways to talk about slope. Visually, when you have a graph, it's going to be the rise related to the run, rise over run. Okay, another way to describe that is rise is the change in your y. So that is a Greek symbol called delta, and delta refers to change in math and science. So the rise is your change in your y's, and the run is the change in your x's. Okay, and so the whole idea of a slope is also a rate of change. Okay, how steep, how not steep, how is the graph going up, going down? It's a rate of change. So that's what your M stands for. That's going to be your pattern. Okay, how do you get from point to point? You're going to go rise and run to get from point to point. Okay, and then our B value is our y-intercept. That is our starting point. So as a coordinate, it is 0 because it's a y-intercept, comma, b. Okay, so how do you graph in this form? First thing is you need to know where to start. That means you're going to plot the y-intercept. Okay, that's where you start. And then once you have that, you need directions, which is applying the slope. Apply slope. AKA rise over run. Multiple times, point to point to point. All right, we're going to do a couple examples for this. So what you're going to see is we're going to do this on these 3 equations. And none of them are actually ready to graph. They're not in slope-intercept form. So we're going to manipulate these and turn them into y equals mx plus b. And once we have it in that, then our graphing is pretty straightforward. Okay, so first thing we got to do is a little bit of manipulation. We always got to get the y by itself. So on this one, we need to bump that 2x over to the other side to get the y by itself. So mathematically, to bump that over, we're going to subtract it over. Okay, so you're going to have a y equals, now they're not like terms. They're not going to be like terms because this one doesn't have an x on it. So it's just going to be a negative 2x plus 4. Now I could switch the order. It could be 4 minus 2x, which is nothing wrong with that at all, but I like to keep it consistent to this look, where that number in the front always refers to my slope and this number in the back always refers to my y-intercept. If I switch that order around, then I got to kind of filter through it a little bit, and I just don't want to do it. So I always put the x first and then the value without the x second, because that's my slope, that's my y-intercept, which is exactly what we're talking about. So, so on this equation, your slope is -2, but you need a rise and a run. So then we just turn it into a fraction by putting it over 1. And the y-intercept is 4, which if it's asked for a coordinate is 0, 4. Okay. All right, so for that graph, we are going to, our equation that we want to pull our information from is our slope-intercept form, which we've already manipulated. We start at 4 on the y-axis, 1, 2, 3, 4. And then we are going down 1 over 1, down 1 over 1. That's what the negative is. So down 1 over 1, down 1 over 1, down 1 over 1. Okay, and we keep on going. or we can go backwards, and we should go backwards. So instead of going down and to the right, we'll go up and to the left to kind of keep that pattern going. And that is our line. Okay, and if we ever want to know if we did this correctly, all we have to do is take one coordinate. So like that coordinate is a 1, 2, and make sure it satisfies the original equation. So if you plug a 1 in for x, which is what that tells you to do, so if you put a 2 times 1 plus the y value, it's supposed to equal 4. That's what all of these coordinates are supposed to do. They're supposed to all add up to 4. So here is 2 plus 2, and that in fact equals our 4. So we could randomly check any points. What I wouldn't do is take the y-intercept, because you can get the y-intercept right, but then the graph you might get wrong, the slope. So if you grab a point off of that, that means you had to do both things right. You had to do the y-intercept right, and you had to do the slope correctly as well. All right. So let's do a couple more real quick. So on this one, we have to manipulate. So we got to subtract the 5x over. Okay, so again, they're not like terms, but don't forget you have a negative attached to your y. So that's negative y equals a negative 5x minus 2. Okay, it's no good to have a negative x here, so we need to make this a positive x by dividing by -1, which means we'll divide everything by -1. So our equation is positive y, positive 5x, and positive 2. Everything got changed. Our slope is 5. Our y-intercept is 2. So the equation that we are graphing is 5x plus 2. And again, we want a rise and a run when we graph this. So our y-intercept is 2. We are up 1, 2, 3, 4, 5 over 1. And we are down 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And they should line up perfectly. Okay, and then we'll do one last. So on this one, same thing. We're going to bump the x over to the other side. That's always our first step. So we'll subtract 3x. Again, they are not like terms. So we'll have a 4y equals a negative 3x minus 12 because of the sign right here. And then we want to isolate the y, so we want to divide by a 4 to cancel that away. But if we do that to everything. So we have a y equals negative 3/4 x minus 3. Okay, so our slope is a negative 3/4. Our y-intercept is a negative 3. And our equation that we are graphing, it looks like this. Okay, and so we'll graph away. So y-intercept at negative 3, so we're down 3. And then we are going down 3 over 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And then we go the other direction. So we'll go up 3, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And that is our, let's try and connect the dots here. Okay, so that is our line. And again, you could grab any point. You could grab this coordinate out here. Again, as long as it's not the x-intercept or the y-intercept, grab that coordinate and plug in those x's and those y's and see if it adds up to negative 12. Okay, and if it does, you graph this thing correctly. Also notice that negative slopes go down, positive slopes go up. We read graphs from left to right. So as this graph is graphing, we're reading this graph from left to right, like time is elapsing and it's going down, which means we had a negative slope. This graph is going up, which meant we had a positive slope. Okay, so that was graphing. That was manipulating some equations into slope-intercept form, which is kind of a graphing form, makes things a lot easier to graph that way.